There are two objectives in lesson 2.2 that we're going to cover. The first one, we're going to spend quite a bit of time on graphing polynomial functions. We have to know the basic shape and design of them. And secondly, we want to use these polynomial functions to model real-world data. So we'll be doing some regressions for curve fitting. First thing they do is they describe what a polynomial function is, because our job is to graph these polynomial functions. So in lesson 2.1, we learned about the basic characteristics of monomial functions, and that's what they're telling us here. Our monomial functions are the most basic polynomial function, and what we're going to do is we're going to do the sums and differences of monomial functions from other types to form other types of polynomial functions. So the biggest thing here that we got to be conscious of, to create a polynomial, n must be a non-negative integer. So all those that we dealt with in lesson 2.1 aren't going to be part of the issues here. We're going to have to make sure that our exponents are going to be positive numbers, and they have to be integers. So we don't have to worry about half, so no square roots. We don't have to worry about thirds, so no cube roots. None of those radical equations are going to be involved in these polynomials. We also don't have to worry about the exponent being negative, which means there are no butterfly graph looks, there are no volcano looks in these. These are polynomial functions, which would be more like our x cubed and x squared, our x to the fourth, x to the fifth graphs, and even linear. So that's the first thing, what a polynomial function is. And they give you some other descriptions here. One of the things I want to pay special attention to is if you have a polynomial function, then they are continuous for all real numbers. They are smooth, they are round. So that's a polynomial function. Here's some obvious things that tell you it's not a polynomial function. Anytime you have gaps or breaks, holes, gaps, breaks, vertical asymptotes, or anytime there's a sharp corner. So we're ruling out the absolute value or any of our piecewise functions that have gaps or jumps in them. Anything with the vertical asymptote is going to be removed. So those will not be polynomial functions. So first thing that they want us to be able to do is they want us to be able to transform some of our parent functions of the monomials. So really this is a matter of visualizing what your parent function is and then being able to do the vertical shifts, translating up and down, left and right. We might be reflecting across the x-axis and so on. So here's our first one. When I look at f of x, I'm thinking in the back of my mind that this function f of x, really the dominant feature is it's got an x cubed. So in my mind I'm thinking I've got a cubic graph, and a cubic graph goes from low to high, and we could locate a few specific places, but just being very general here. It goes through 0, 0, the order pair 1, 1, negative 1, negative 1, 2, 8, and so on. But what's one of the things that we got to do to this graph? Well, one of the things that we see is that there's a negative in front. So if you wanted to, if it makes more sense, it's a 4. We can put plus a negative x to the third. The reason I'm highlighting this is this negative is going to flip your parent graph about the x-axis. So this is a reflection across the x-axis. So now it's coming down this way, which means our ordered pairs have to get turned around. So the ordered pair 1, 1 now becomes the ordered pair 1, negative 1. And this ordered pair that was negative 1 becomes negative 1, positive 1. So we reflect across the x-axis. Then the next thing that happens is we have a positive 4. Now this positive 4 is outside the grouping symbol. It's not within the cubed term. So that's a vertical translation. So the vertical translation is going to move this green graph up 4 units, and then we can slide our graph upward from there. Okay, so using your transformations, your concepts that you learned in the previous unit about how to slide things up, down, left, right. So when we graph these, this is the expectation that you can graph without use of technology. So there's no calculator that's going to be involved in this. So that's why I said to a few people in class today, there will be a non-calculator portion on your quiz and assessments, tests, or quizzes. Okay, so that's the first one. Okay, in 1b, I look at the dominant feature here. The dominant feature is that it is raised to the 4th power. So I'm thinking g of x is a modification of the x to the 4th monomial. So what did we do to this polynomial, or what did we do to our monomial? What we did is we added 7 inside the grouping symbols. So what we learned is anytime you affect the input values first and then you do something to it, that is a horizontal. Horizontals are counterintuitive, so when you see the plus 7, it really is moving it left 7 units. So we want to go 7 units left with our graph. Okay, so we do have to have a little bit of a concept of what x to the fourth meant and what that graph looked like. So our x to the fourth graph, our anchor points 1 and negative 1. We take 1 to the fourth power, it's 1. We take a negative 1 to the fourth power, it's still 1. It was our U shape, but it was wider on the inside and steeper on the outside. So it's just like our x squared graph. They're going to be U-shaped, but the difference is on this one is we're going to move it 7 units left. So when I get done with this curve, I want it to be 7 units to the left, and I want it to smile. So 1, 2, 3, 4, 5, 6, 7. I still want it to smile, but I want it to be wider 1 unit to the left and to the right of 7. So here's our negative 7. Our main features are a negative 6 and a negative 8. 1 unit up, 1 unit out, 1 unit to the left, 1 unit up. And that's kind of our points that move along with our graph very easily. And it's going to be wider along the base and then sharper on the outside. Wide on the inside, sharp on the outside. And in a perfect world, this graph would be right down in that 0 point at the negative 7. So we're going to use our transformations that we learned in Chapter 1, and we're going to apply them to these monomials to graph polynomial functions. So that's the first thing they expect you to know how to do.